Hi, welcome to the this month's virtual JBook. So this month we have Christian Posta, who is a solutions architect from Red Hat. So he's going to be talking about microservices, and he's going to cut through all the hype that's surrounding this architecture. Christian's also going to talk about how open source software can help you be successful with microservices. So thanks a lot for coming, Christian. Thanks for doing this talk for us.
Sure, happy to be here. Thanks for having me.
Excellent, thanks. Yeah, do you just want to begin by introduce yourself so you can kick off the talk to know who you are?
Yeah, my name is Christian Posta. I am a principal middleware architect at Red Hat. I focus on integration and SOA and microservices and how all that stuff makes sense in a cloud world. So one of the key aspects of this talk here is going to be not just from a technological standpoint, which is obviously important, that needs to be there. There's a lot of good tools, and we'll talk about those, but from an organizational standpoint as well.
Oh, sorry, I was just muted. All right, okay, that sounds good. Thanks, Christian. Yeah, do you want to kick your talk off?
Yep, let's do it. Let me share screen. Yeah.
Okay, I'm just going to mute.
So you guys should be seeing my desktop right now. The demo that I'll be giving later, I just had to restart from scratch because, of course, moments before the talk, the entire environment went to crap. So we're crossing our fingers big time with that.
So Christian, we're seeing a blank screen at the moment.
Oh, you're seeing a blank screen?
Yeah. Are you running dual monitors?
No, I'm on a single monitor, just my laptop specifically for this. Let me stop sharing that.
You can see you now. It worked.
It did work.
I think it was just slow coming through.
Okay, let me know if that's a problem going forward then, because I am kind of downloading the internet for my demo here.
Yeah, it looks good. It's fine now.
Okay, maybe there's a momentary lag there. All right, then let's get started. The name of the talk is there on the screen, and what we're going to look at is so everyone's talking about microservices. Microservices is a very hyped topic. You're going to see it at any developer conference, regardless of the technology. You'll see mention of this and DevOps and cloud native and all this stuff. But really, the focus of this talk is why well, I mean, this part isn't new. Why hyped technologies or approaches, they might not fully deliver. But I mean, we've been talking about improving software development and improving delivery schemes for years. Most recently with the SOA hype, and before that with the distributed client server and Corba and Java EE and DCOM and all these different technologies and approaches that were supposed to help us, be more agile and deliver software faster. But so now, why is microservices going to be different, or will it be different, or will it just suffer from the same problems that plague the other approaches? And that's what I'm here to discuss. So my name is Christian Posta. Like I said, I'm a principal middleware architect at Red Hat. I'm a committer on some of these open source projects. I'm very into open source and collaborative approaches and open organizations and that kind of stuff. I've spent a lot of time working with a client that happened to be one of the internet scale unicorn companies that are now being heralded as the microservices examples. So I got a lot of time deep with them to understand how they do things, why they do things, and so on. And I enjoy talking about this stuff and blogging about it. So feel free to follow me on Twitter. I link to a bunch of interesting articles, and I also try to write my own. So you're thinking about doing microservices. Everyone's thinking about it. Everyone's talking about it. No one's really doing it yet, or at least the main big internet unicorn companies that are doing it. They're doing it differently than it seems that the big enterprises are starting to look at it. So when we go down this path, we have to understand why and start to dig at why the environment, or why organizations are not fully implementing the past hypes, to be able to understand how do we go forward with this new hype. And part of the intro to this talk won't be terribly new to you, but it is important nevertheless to understand how businesses work today and how they worked in the past. So obviously we have the internet. That's not new. We have social media. It's taking over. The millennials are going crazy with all the social network stuff, being able to post updates and share statuses and all this stuff. But really, the way this impacts companies from a marketing perspective is it turns the previously held truths upside down. In the past, companies would market to us by TV advertisements or legacy media, and it was a one-way communication with us. They would bombard us with this stuff. And we now have various channels for this interaction, and we can interact back with the customers. Or with the companies. They have to pay more attention to us. Different tweets and blogs and videos and so on can go viral, and bad customer experiences can go viral and really damage the reputation of a company, as well as new up-and-coming technologies or services. Those can also go viral and ripple through a social network, and those can very quickly become overnight sensations. So with the underlying pinnings, the way we interact with each other changing and completely changed from how it was before, and with technology itself being so cheap, you can go off and spin up for a few pennies a handful of instances on Amazon EC2 and hack some Node.js and integrate with Postgres or something, or any of these NoSQL databases. Very, very minimal effort and cost in being able to try something new and experiment. So with those two pieces coming together, companies are at they're being forced to revisit how they develop their solutions, how they stay competitive, and it will force them to continue to change. I love this quote from former CEO at GE that says, if change is happening on the outside faster than on the inside, then the end is very close. It's insight. So how do we keep this promise from the technology side with the business and allow us to move quickly and be able to change? Well, a lot of this comes from software. And software by its very nature is soft, right? It's malleable. It's like clay. You can change it and shape it and redo it or throw it away and start over. So that's a good foundation. But we've been using software for 30 years or longer, and we've come from the premise of developing software the same way that we architected assembly lines, right? We started off with the waterfall model, and everything goes through design or requirements, and then design and test, and all move it along. And we found this to be very, very much a bottleneck. It didn't respond to changes in the environment, and with software, it's malleable. We want to be able to change it, so we have this process. Let's look at other things like agile methodologies and Scrum and all those things, and try to be adaptive and responsive to change. But even with those, people have various understandings of Agile, various different implementations. It still isn't, Agile itself isn't the silver bullet, isn't the solution. There's still problems with that. Now, maybe that's because if we start to look at how companies were originally, for decades or centuries even, how they've been organized for a very, very long time, that is with the focus on producing products. So you would take a handful of supplies, different vendors, different partners, take those raw materials, pump them into this factory with well-defined processes and reliable outputs, consistent outputs, and they churn out all this product and then sell it off to the customer. And for the last decade or century or so, we've, with the Industrial Revolution and all that, we've been buying products, hand over fist. But we're getting to the point in our markets where we're becoming very saturated with products. We have cell phones and microwaves and TVs and cars, and I have a cell phone, but I'm not going to go out and buy 5 more cell phones. I have a garage full of crap that my wife wants me to clean out. We are saturated with product, and so this is not where the story ends, because businesses still want to be competitive and drive value. So how are they doing that? They're doing it through service, and not just service, but they're doing it through differentiated customer experiences. So there's still product, they're still creating products, but they're using these products as a platform for delivering service. And this isn't just limited to technology companies, like I have a handful of them up here, but companies like Whole Foods and Nordstrom's have geared their entire operations around having a platform for their employees to use to deliver the best customer experience. For example, at Nordstrom's, you can walk into Nordstrom's, and the store being the platform there, the employees are not tied or tethered to a very specific department where they are specialized in shoes, for example. You can walk into Nordstrom's, and the customer service rep there can help you with any part of the store. They can help you with shoes and take you to ties and makeup and whatever. So the entire culture there at Nordstrom's is built for their individual employees having the autonomy to be able to do what's reasonable to provide outstanding customer service. Our companies were not built for customer service. Just think how many times you've called into a telco for customer service and you're greeted with an automated voice system trying to tell you what your problem guide you through the step. Built for centuries. They're focused on very, very high levels of efficiency and repeatability. They organize by specializations and try to break down into even further specializations and try to eliminate and reduce variability. But customer service isn't built on efficiency. It's built on that variability, that variety. But the more we start to specialize and cut the organization down into these small silos, we start to see some problems that are impediments to being agile and responsive and enable variety. We see that the individual teams, they have communication issues between them. We have an entire movement in the IT industry called DevOps that's aimed at solving some of this. The more of those synchronization points that you have, the more you start to congest the engine, the company, and the more difficult it is to get things done. The second part is the more you silo and isolate people into these specializations, the more they lose perspective, the more they lose and they don't understand and don't fully care what the purpose is of the company, of the organization, or of even the specialization adjacent to them. And that's why I love this quote: the more you isolate people, the more you treat them like cogs in a machine, the more they just act like cogs in a machine. And they're unable to understand the company's values and what it takes to solve customer problems and interpret the feedback that you're getting from customers in any sort of way to solve their real problems. So ultimately, our companies are made of people, and people win. The way people organize, that wins. When you're trying to build an organization or try to build a system that is agile, having rigid structure and having top-down hierarchies and specializations and synchronization points and all this stuff really makes things rigid. So it's not a surprise that all of these precursors to microservices and SOA and all these technology-focused solutions may not have been delivering while they've been promised, because we're not paying attention to the bigger picture. So what is it that I'm saying? So you want to develop culture, cooperate with your customers in a mutually beneficial way. So how do you get there? Well, what if we stopped thinking about companies as machines and started thinking about them as groups of people, and started looking at other examples that either nature provides or the markets provide that show a group of people coming together to innovate and experiment and deliver value through their ability to stay agile. So what if we thought about organizations as complex adaptive systems? A complex adaptive system is a type of open system where agents, or in this case in companies, groups of people, can interact with their surroundings, and they have autonomy and can make decisions on their own, and the collective ability of all these autonomous groups and their ability to respond and change and adapt individually is what brings the much larger environment that level of resiliency and agility that big organizations are looking for. So if we start to look at organizations as complex adaptive systems, then maybe this so-called Conway's Law that pops up in all of the microservices talks, maybe this starts to make more sense. If we're being told that we're designing systems in such a crappy way, but we don't understand why, then we're going to continue to do that. And with all this talk about microservices and lines of code and breaking things down into smaller pieces and all that stuff, that's just going to create an even bigger mess than we have today. So understanding the core principles around why and how these information systems are to be designed, and if they're to be designed in an agile, loosely coupled way, then we've got to start with the foundations, and that being the way we organize ourselves. So my position and the cold hard truth part of this talk is that the success stories that we hear about microservices from the big internet unicorn companies is less about the technology they use. So who cares if they're using Spring Boot or Docker or Amazon EC2 or whatever. The real success story is that these organizations have made that transformation to something that looks much more like a complex adaptive system. When so this client that I went to go work with, one of the very first days, I asked them, so can you give me an idea of what the architecture looks like? Can you give me some diagrams or anything like that? And they said, no, we don't even know what it looks like. It's a big ball of tangled service calls, and there's not one canonical snapshot of what it all looks like. It's constantly changing, and we don't really know. We don't really care what it looks like. It's working. And the same thing with Netflix. Adrian Cockcroft was asked about the organizational structure of his organization back when he was there, and he said we don't know. It's adaptive, and it works. Kind of like these diagrams here. One of them is the Netflix example, and they evolve and adapt based on customer input and based on the purpose of each one of those little agents, and they together collectively produce great things. So what does this have to do with open source? Well, if we're starting to look, if we want to look at it at organizational structure and building systems, information systems through a different lens, we have a very, very good example right in front of us, and that is the open source communities. The way they work with each other, the way their decoupled from each other, the way they're able to stay resilient and innovate and experiment and try new things. And there's a book written by the CEO of the company that I work for, Red Hat, the Open Organization, that talks about leading a company in this direction and using the principles from the open source communities, such as transparency and feedback and autonomy and all of the prerequisites to an organizational structure that enables this sort of adaptive design. So for example, I do a lot of work in open source communities, and the way we communicate with each other is incredibly transparent for the most part. Everything, if it didn't happen on a mailing list or IRC, then it didn't happen. That way, everyone can see and collaborate and understand what the decisions are, what the pros and cons are, and contribute to it. And then with the ability to get feedback at the group level, at the product level once they've deployed something. We all have JIRAs and, like I said, the mailing lists, and if you deploy something or make a change, you can get instantaneous feedback from the community because it's all open. These communities are fairly autonomous. So, for example, I work a little bit in the ActiveMQ community, and that is a community with a purpose and is driven toward building a awesome messaging product that is not that can compete with the main vendor, the big commercial vendors. But we're not tied to what Hadoop does. We don't, there's not one person or set of people who's at Apache who's saying, well, you must do it this way. They're providing us a platform. They're giving us Jira and SVN or Git and wikis and all the platforms, specific things that you might need to go off and be creative. And in these open source communities, we're constantly trying new things. We're evaluating how things were done and changing them, and with the with the purpose of experimentation and wanting to invent something cool and play with something cool. But ultimately, that spins off at times into very popular open source projects. Okay, so all of this rambling about organization, about the way companies were designed, about open source. Will this help me with microservices? So the key to take away from the organizational structure talk is that focusing on groups with autonomy will help reduce dependencies between teams and allow them to take decisions and take actions on their own without having to consult with and synchronize with other teams. And this is exactly the type of interaction and structure we want with our information systems, with our microservices. So to me, microservice is really a way to organize teams for autonomy, which then gives scalability. Individual services and individual teams can move faster without the synchronization points, and the ability to manage complexity, business complexity and software complexity, at the expense of known trade-offs, because as we know, there is no silver bullet. So when do you do microservices? Well, you do it when you have a scaling problem. Netflix and some of these other big companies had a certain type of scaling problem that could be met by simplifying things and doing microservices. Do you need to deliver software faster? And microservices helps with that. The DevOps movement is also very, very much involved with that, and also with how it ties in with culture and organization, as well as organizational complexity concerns. So I'm not going to go off too much into the benefits of this approach. I don't want to continue to beat the dead horse. Everybody's going around talking about it, and talking about it as though it was a silver bullet, but it's not a silver bullet. There are drawbacks to designing systems out of these autonomous components. The operational complexity goes up. It's not very easy to do. Designing APIs, designing bounded contexts, and organizing teams around bounded contexts is not an easy thing to do, and it's not something you just start off doing. It's something you evolve into. At times, you'll find that the resource overhead and network chattiness between services can cause trouble. There's lack of tooling in various parts of it, although the open source community is in part working to close some of those gaps. But so doing this approach, doing microservices approach, is a concerted effort between your architects, your developers, your operations teams, and the business, and even how they organize all of those components together. So just like in any complex adaptive system, emergent behavior from these agents, the innovation that happens from these agents is usually provided by the autonomy and by a platform. There's some platform, some common set of understandings between the agents, and that helps them get a leg up and get going in the right direction to be able to deliver the services and applications that the business requires. So from the standpoint of a microservices platform, and this is not unique, I would say, to microservices, but it's often talked about, but it's really a distributed system platform that provides things like service discovery. So being able to discover services at runtime and not be tied to environmental specific permutations or dependencies. So to enable some of the continuous delivery type automation that we want to be able to discover services in our surroundings. To be able to manage configurations and have repeatable builds and repeatable deploys so that we can build any sort of CI/CD, we want to look at immutable infrastructure type deployments. And then once you have your services out there and you have your interfaces and so on, you need to be able to manage access to those through API management, and then being able to tie together some of the tooling aspects and the insight or knowledge about what's happening with your services. You want some sort of centralized logging and metrics and monitoring solution. And when you're adhering to the CI/CD automation practices, you would like, so it would be nice if you could customize it, customize a pipeline and tailor it to your project, but that the platform does all of the heavy lifting for you. And crossing my fingers, when we get into the demo, that's hopefully what we'll be able to show. So what would a platform like that look like? Well, for the immutable infrastructure pieces and the dependency management pieces, we've, at Red Hat, we've gone full in, invested into the Docker ecosystem, the Docker image format, for being able to package and move applications. And then on top of that, we've invested very heavily into the coordinator or orchestration engine that places containers onto physical hosts and schedules them a certain way and make sure that they're available, and if they go down, restart them somewhere else. And we've taken that premise, that foundational those raw pieces, and built them into a product called OpenShift. Now, OpenShift uses those raw pieces and adds a layer of developer-focused workflow and tooling. So not having to worry about the underlying raw pieces and their APIs and Docker packaging and all that stuff if you don't want to. And as a developer, there's going to be times and scenarios where you just want to work on your code and push your code into this platform and have it evolve the rest of those microservices requirements for you. OpenShift has what's called S2I, so that's the source to image builders, where you push your code up into a Git repo, and then OpenShift triggers the builds of your software, regardless of the technology, and handles things in a very uniform way. There's also triggers built into the system to be able to regenerate builds and regenerate deployments on demand. Some of the raw pieces, Docker and Kubernetes, don't come with a suitable software-defined network, so OpenShift provides the ability to hook in with existing existing infrastructure and be able to reach the services that you're actually deploying. And there's the CLI and web-based tooling right now, which will continue to evolve. But basically, it's a outlet or a portal for developers in a very developer-focused way of using the container technology underneath. Now, Fabricate is an open source community that aims to bring the automated continuous integration, continuous delivery pieces, the API management, the integration pieces, the chaos monkey type stuff. So all of the components that you would want to see in a microservices platform. Fabricate v1, which was implemented with Zookeeper and very focused on certain types of Java JVMs, and provided distributed configuration management and service discovery and all that stuff. Very similar to what Spring Cloud does today, I would say, if you're familiar with that. But Fabricate v2 and OpenShift and Kubernetes takes a very different approach, so as to not tie to any specific framework and not force you to use specific client libraries to enable some of these features. We'll use the built-in Kubernetes service discovery, for example. And since we're using Docker, we can use any technology. It doesn't have to be just JVM or just very specific JVMs. All of the manual configuration of VMs and the networking between them and security between them and all that stuff is handled for you by the platform now. Here's a quick screenshot of what some of the apps that come inside that come prepackaged with Fabricate. And knocking on wood and time permitting, looks like we're good on time. We're going to see how our demo looks. All right. So this is the Fabricate console. The Fabricate console gives a view of this part is very specific to Kubernetes. We can click on projects and we can click on logs and chat, and I'll do that in a second. But looking at Kubernetes tab here, we can see all of the Kubernetes services that are deployed. And now these are, I didn't go into what these terms are, but that is a talk on its own. But the different Kubernetes components are listed out here. The replication controllers, which control the number of pods or number of containers that are running in the cluster. So, for example, all of these are very simple. They're just one. We just want one container, one Docker container, basically. The pods, which is where the containers run, we can see exactly where they're deployed, how long they've been up, different Kubernetes labels and so on that you can build services around. We can see this is very simple. We're just using the come here to fabricate.io. Let me make this full screen. We're using, if you look on the documentation, the user guide, we're using the Vagrant image that comes out of the box for you, which has OpenShift, has Fabricate all installed for you. All you do is do a git clone of this folder and do Vagrant up, and then it goes installs and puts everything together for you, just like I have here in the demo. So we can also pre-package applications and groups of Docker containers that work together. In OpenShift, yeah.
Hi, is it possible to zoom in just to make that big?
Yeah. Let me make that one full screen, and I don't want to. Okay, is that good?
I think so. Can you see it at the back? Yeah. Excellent. Yeah, that's great. Thank you.
Okay, awesome. So we also have, OpenShift has this concept of templates and being able to reuse groups of applications by, you plug in a couple of parameters and it'll spin them up for you. And Fabricate has, out of the box, a handful of templates that can be used for API management, for C delivery, for continuous delivery, which is that's the app that I ran. So when we see all of the services such as Garrett and Gogs and Jenkins, those all come from running this C delivery app. So it automatically installed all that stuff for us. The Chaos Monkey, which I will install in a second, and then all the integration related pieces that rely a lot on Apache Camel and logging and management, all these different apps, Prometheus for monitoring, that allow you to just give one-click functionality to deployment. Let me give you an example of that. So if I click on this Chaos Monkey app, we should see Chaos Monkey is going to attach up to a chat room and is going to show us all of the pods that it'll kill. Right? The Chaos Monkey is about ensuring that your distributed systems are built to be highly available, built to be resilient, and not just taking your word for it. The Chaos Monkey will go out there and destroy the pods to enforce that. But before I run Chaos Monkey, let's actually deploy something, one of our projects. So if I click on Projects and I click Sign In, and what this is going to do is this is going to log into the project build system or the project system. And when I ran that C delivery app, I showed you, and I'll show you again real quick, that it installed a handful of services. So C delivery allows you to do code reviews. It has a built-in Jenkins. Here, let's fire it up. It has a built-in Git hosting repository called Gogs. So it brought all of these pieces up for us. It has a Nexus for artifact repositories. There's also a Let's Chat. So for doing DevOps has a few principles that it tries to convey, and one of those is, so you got culture and automation and measuring and sharing. And by doing something called chat ops, which is another philosophy around sharing, the sharing part of DevOps, you use chat, and you use chat rooms, and you use chat bots and so on to improve the transparency of your team, so that they can see what each others are doing, and they can automate things directly from the chat room, and increase the communication between a small team. So let me log into this real quick. Account. As I said, I blew away the demo environment 2 minutes before we started doing this. Let's log in. We should have a Fabricate room, which we do. And there are not too many people in this room. It's just me and the Fabricate bot. And the Fabricate bot, we can give commands to, tell it to deploy our applications, for example, or approve deployments, which we'll see here in a second. Knock on wood. So I come back here to projects, and when I sign in, real quick. We are going to, so this would list the set of repositories, the Git repositories that we have. When I sign in here, we should see we don't have any. Don't have any repositories. This would show the OpenShift build configs that we have, but we don't have any of the active builds or deploys and Docker registries. We don't have any of that stuff yet. All right. One second as it thinks through things here. All right, we're going to click Create Project, and we're going to create a new project. We're going to call it demo, and we'll call it the JBug demo. I'm going to create a new Java application from a Maven archetype, and in the next step, we'll choose the catalog that we'll use. Right now, we just have a couple plugged in, but you can plug in your own. And we'll do a very simple CDI-based project. So this CDI-based project would basically be a flat class loader style project that uses CDI to do dependency injection. Now I click Execute. What this is going to do is allow me, so it's going to set up the project, it's going to set up the repositories, but it's also going to allow me to specify a continuous integration and continuous delivery flow or pipeline. And out of the box, we have a collection of these pipelines that are built using the Jenkins workflow DSL. So with that DSL, you can specify the individual steps and parameterize them. You can include approval, and so human approval, human promotion type steps, which are key to any serious continuous integration and continuous delivery pipeline. So we'll pick the stage and approve pipeline, and we'll hook it up with our Fabricate default chat room. So what this means is, so when I click on execute now, it's going to go create the Git repos. It's going to install the project in there. It'll create the necessary Jenkins workflows in Jenkins, and we'll kick them off for the very first time. And all of the build artifacts are automatically connected up into Nexus, the Sonatype Nexus. So if you're doing a Java build, it'll install the Java artifacts into Nexus automatically for you, and it'll have a very simple approve or promotion gate, and a human has to be involved to promote it. And when it deploys these applications, it's going to deploy them as Docker containers, and is going to use OpenShift projects or Kubernetes namespaces to deploy these Docker containers. So if I click Done here, we should come over here to Gogs and do a refresh. We should see now our JBug demo is the source code is here. We created it from that Maven archetype. There's a fabricate.yaml file here that allows us to control parts of the CI/CD process and which components will be involved. So for example, we see here code review is false, but if we change that to true, then it will force changes to go through Garrett, where you have a centralized code review process. So we have this Java application here. If we go to Jenkins, we should refresh, and we should see that there is a Gogs admin JBug demo. So that is the Jenkins workflow that the platform automatically created for us. If I look at the workflow steps, we can see that we're at the beginning and we're doing a Maven install, I think. So we click on console output. Oh, looks like we're downloading Maven. We're installing Maven. So before we download the world with Maven, we have to download Maven. We'll give that a couple of seconds, but what'll happen then is it'll install Maven, and then it'll do a Maven install on the project, and the project actually has tests here. So that Maven archetype also produced a set of integration tests based on top of JUnit. And what Fabricate allows you to do, it has a client library that allows you to inject Kubernetes resources into the test and use those to assert certain types of behavior characteristics about the deployment. So as we run our unit tests and we get to our integrations tests, what the platform is going to do is take that Java project, build it up as a Docker image deploy it to Kubernetes or to OpenShift, and then allow our unit tests to run directly against that deployed instance. So no more fumbling around with, I don't know if you're familiar with JBoss Fuse, and we have certain types of integration test frameworks that you have to use, or configuring locally on your box or on the build server to use a specific application server, and then it works on your laptop but not on the build box laptop. So everything is going to be going into a Docker container and deployed into the platform. And so the download for Maven is taking a bit of time here, but if this were to properly proceed, then what we would see is the application gets deployed into Kubernetes. We would have a chat notification right here in the chat room that allows us to approve or deny the build. So if we deny it, then everything, it won't roll up into production or any further staging environments. If we approve it, then it will be promoted to the next stage. In this case, in the demo, would have been from QA to production. And what we're working on is allowing multiple different types of promotion scenarios, so that if you want to do it in your chat room, whether it's Let's Chat or Slack or River or whatever, then you can do it that way. If you want to do it from within Garrett as a code review step, so that once builds make it to QA, then it'll send a trigger off to Garrett that says, hey, we want to make a change to prod. Now somebody needs to go in there and manually review it and approve it, so we can have that approval process through Garrett. And then we also want to allow the approval process to be made through an issue tracker, like a Jira or something. So unfortunately, I don't know if it's the bandwidth on my machine here, but it's taking a little while to download Maven. I will have a shortened version of this demo that I'll publish on my blog. So with that, I don't know if there's it's getting close on time here, so I'll take questions if there are any questions.
Thanks, Christian. I'm just going to ask in the chat room, and then I'll ask in the room here. Does anyone have any questions, Christian? So I've got a couple, so I'll kick things off. So one of the things I wasn't quite clear on is where is Fabricate hosted? Are you running that on OpenShift? Is it on your own instance, or is it hosted? Is it software as a service? What is it?
Right. So it is a set of services that can run on top of OpenShift, that can run on top of Google Container Engine, can run on top of any Kubernetes API-based platform. So it's not a SaaS. It's not a SaaS model. It's to be deployed locally or privately on your own infrastructure.
Okay, that makes sense. Okay, and then you say it's running on OpenShift. So you mentioned Kubernetes. So do we need OpenShift v3, or does it work on OpenShift v2 as well?
It is specifically tied to the Kubernetes v1 API. So that would be OpenShift version 3.
Okay, so it's not
3.x.
So you can't use it on OpenShift Online yet?
Not yet, no. Okay. Not until there's an OpenShift v3, OpenShift Online.
Okay, so at the moment you need OpenShift Enterprise, so on-premise, or you need to run on Google's.
Or OpenShift Origin.
Okay, right, yes, of course. Yeah, so you can run the open source, you can run the project yourself, OpenShift.
Yeah,
okay, that makes sense.
And actually, just for, I guess for the people that this would apply to, I am next week on Thursday going to be in Boston giving a Fuse on OpenShift workshop, which is free to the public. That I'll be showing off some of this stuff.
So that sounds interesting. Okay. So if people want to, so it looks really interesting what you were doing. So if people want to go and try that themselves, what do you recommend the easiest way that they can do that?
Yeah, the absolute easiest way is to come to fabricate.io and click on the Vagrant image getting started. The Vagrant image getting started is absolutely the easiest way to get started. If you have Vagrant on your machine, then you just grab the Vagrant file and do Vagrant up, and it'll download it'll basically download the operating system, it'll download OpenShift, and it'll put Fabricate on top of OpenShift. And you can, there's even steps for setting up the OpenShift client and all that stuff, so you can create or log in directly to that Vagrant image.
Okay, sounds relatively straightforward.
And then after that, you can install it natively on top of an OpenShift deployment or whatever other options you wanted to look at. There's guides for them here. And the Fabricate IRC channel and the Fabricate mailing list are very active. So if you have questions or issues trying to set it up, then don't hesitate to jump on there and ask.
Okay, so yeah, another question I had was, do you have any integration with pull requests? So if someone raises a pull request and if you change to your code, will that go and kick off a build and test it?
Yeah, exactly. So a commit to the master branch. So if we go back and look at, we had GOGs here. If we have a change or a commit to this master branch, however it gets in there, either via pull request or by a Garrett approval, patch set approval, then that will trigger a build on the Jenkins side. And actually, while we're here, this thing continued on, and we're actually at that point where the build succeeded and was deployed into a QA environment. And now if we go to the chat room, we should be able to, it'll tell us that our application has been staged, and if we want to proceed, we can reply proceed or abort the build. But yeah, so a pull request or Jenkins or Garrett patch set would kick off one of these builds. If I say proceed, then the chatbot tells me that they're going to proceed with the deployment to promote this to production. If we come back over to the Fabricate console and click on Kubernetes, click on the staging one. So this would have been the QA staging environment, and if the deployment succeeds to prod, which it did there, then we should see the demo, or sorry, the prod environment as well, and see that it was deployed there. But yeah, that's how you would trigger the builds at the moment.
But what happens if so you say that you merge the pull request, and then once it's merged, that kicks off the build pipeline.
Mm-hmm.
But what happens if you want to test the pull request before it's merged?
So test it inside of a deployment, or inside of Kubernetes, or inside of OpenShift?
Yes, if you were to fire up a build based on just that pull request, and then run some tests on it before you merge it into master.
So that's not something that happens right now, but that is something that we did have implemented on the Garrett side before that broke. So there is some limited functionality like that, or at least it was working, where if you would submit a Garrett patch set, then that would trigger Jenkins to go do the build first before even alerting humans to come look at it for code review or any of that. So well before it even got merged into master. So that was there, and we'll try to bring that back from the GitHub side or the Git or the GOG side. You know, how you handle pull requests before they're merged into master. We don't have anything for that right now, but we can open an issue and encourage anyone who's interested to come help us.
It's open source.
What's Garrett, by the way?
Garrett is a code review tool. So that allows you to look at change sets, so entire change sets, not just individual commits and some of the noise that might get generated in pull requests. So it's a sort of it's two different models for approving changes to a project. It is used, I think, by the Android community, by the OpenStack community, and a couple of big communities to help. Obviously, part of the problem with continuous integration is people start doing it, they start committing to master, starts breaking the builds, and then nobody goes and follows up and fixes it. With Garrett, you keep the master clean by having separate branches for the changes as they're being reviewed, and it also fosters sort of communication, understanding amongst the rest of the team about what is being changed in the software. So it's a popular code review tool.
Okay. Is Fabricate 1.0? What is it? What's the status?
So the 1.x line is what's being productized in JBoss Fuse, and it is on the JBoss Fuse GitHub, but it's in terms of community, it's everything's moved over to Fabricate v2.
Okay, cool.
Any other questions?
Is there a project per microservice, just out of interest? Like, you know, when you're doing this, would you normally set up like a different project for, say, the account management and one for like customer management?
Yeah, exactly. So you would have different projects for your different services. Those services can all be deployed into a single environment. So like we see that this right here is actually tied to a service per environment, but really what you would set it up to deploy into a set of microservices would be deployed into a single environment, so that they can leverage service discovery and the type of communication between the services that you would expect in a OpenShift project or a Kubernetes namespace.
And how does the service discovery side of things work?
So Kubernetes has three main concepts. Pods, which are basically containers. They're containers that so a single pod can be one or many containers that enforces that all of those containers be deployed together and on the same host, so that you don't have containers split across hosts. So a pod is an atomic unit inside of Kubernetes that enforces affinity rules between the containers. Controllers, another concept, that the replication controllers enforce the number of pods that should be deployed at a given time. And it also monitors, so you can plug in health checks and that kind of thing to not only see if the containers, the Linux containers have gone away, but whether or not the service that run inside the container is even a viable service. So the replication controllers handle the number of replicas, the number of pods that should be running at a given time. Now services, they know where individual pods are, and the pods can be grouped in such a way. So for example, you have 5 web server pods and then 3 Postgres pods. With services, you can label the pods as these are the web server ones and these are the database ones, and you can create a pseudo entity inside of Kubernetes that knows where those 5 web server pods are and how to communicate with them and their IPs, and is able to load balance across the 5. And all you have to know is the location of that service, which is specified as an IP address. And so that IP address gets injected into your dependent pods as an environment variable, just as everything in Docker config sort of gets injected as an environment variable. And then you use that IP to discover the 5 web server pods. Now, if one goes away, then the replica controller will bring up another one, and the service, as far as its consumer is concerned, doesn't change. You're still talking to the same service, and all of the pods running in the back end are transparent, or hidden rather, obscured. You don't need to know about them.
can you have different versions of the services in like different pods then? Like if you wanted to, like if.
So right now you'd probably do that through some application-specific way, or if you're, like, for example, an HTTP service, you'd have a context path, one that refers to version 1, one that refers to version 2. You could also have a different group of Kubernetes services that implements a different version, but then your application would have to know which service to talk to for which version.
You could also do it through labels, couldn't you, in Kubernetes? If you really wanted to.
Yeah. Yeah, so you could label your pods and then use services to discover those pods based on the labels.
And are there any restrictions on the languages that the microservices are written in? For example, could you write them in COBOL?
Where would you run it? Whatever will run on Linux.
Okay.
Is it possible to demo the logging and metrics aspect of Fabricate?
Yes. Probably won't be able to do it right now, but if you go to, there's a microservices event day that some of the Red Hat folks did in London a few months ago. So in here, one of the guys on the Fabricate team, Jimmy Dyson, did a really good demonstration of the logging and metrics capabilities that Fabricate has out of the box. But so if you go to this link, and my internet is really slow.
I don't think we're going to be able to see that link. The resolution's not great.
It's possible to like send it to you.
Yeah. Yeah, I can definitely get it to you. For people who are watching.
So right here. That was one of the sessions. I don't know if my screen's still sharing there, but yeah, Jimmy Dyson did one, and I've been planning on doing one of those demos as well, and probably have one ready for the integration workshop that we do next week in Boston. So I would try to put that on my blog or tweet it or put it up on the Fabricate website.
Yeah. If you send me a link, Christian, then
yep.
we'll put it in the comments of the YouTube video as well. So if you're watching this video and it's not live, then just look in the comments, and it'll be there.
Yep.
Yeah, I was wondering whether it's something that Fabricate completely takes care of for you somehow magically. So if you deployed some project called the JBoss demo or something, whether the logging and metric stuff was like somehow magically enabled.
So as far as I know, and maybe this changed or maybe I'm way off, but the Docker containers natively, their approach to logging is to just log to system out or to the output stream. But then I think there's one manual step to configure, maybe it's FluentD on each one of the nodes. But then after that, all the containers that run on that node the FluentD process will be able to aggregate all of the logs from all of the containers and into a centralized, for example, Elasticsearch or Kibana. Let's see, did I close that?
So I guess that's the bit I was thinking about, does Fabricate magically do? Because I know on Google Container Engine, it does that for you.
Yeah.
So basically, yeah, they just add a FluentD daemon on every node that pushes up logs to a certain thing. I was wondering what Fabricate do on top of that.
I think it's very, very similar. Let's see. So here's the Kibana website. I don't know. Yeah, I don't know if the demo's hosed for that part of the functionality, but yeah, basically it grabs the Docker logs from the output stream and then pumps them into a centralized logging framework like Elasticsearch with FluentD living on the nodes. But I think FluentD has to be installed on the nodes separately. But then after that, the Elasticsearch and Kibana web page and the InfluxDB and all that stuff is set up for you.
Cool.
I've got a question from IRC in the web chat. So, do I have to use the Fabricate built-in Let's Chat and GOGS, or could I integrate with, for example, GitHub.com and Slack?
Yeah, the whole reasoning behind that is we'll provide something out of the box for you with one click when you go install that app. But if you want to swap out the individual components, you absolutely can. So yes, if you want to use GitHub or GitHub Enterprise, then go for it. Just swap it out. The API that we use to interact with GOGS right now, so GOGS implements part of the GitHub API. So switching it out to GitHub should be no problem.
Okay, so does that, which it should be no problem, you mean, does it require implementation work on Fabricate, or is it something that...
GitHub should work out of the box, because before we had GOGS working in there correctly, GitHub was in there. We used GitHub, but I don't know how many people have tried it recently. But so if it doesn't work, then that's definitely a bug. It should work.
Yeah. And what about different chat clients?
The chat room and the automation built into the chat room is provided by Hubot, and Hubot is a sort of a chat ops bot written by GitHub and is agnostic of the underlying chat implementation. So it could be Let's Chat, it could be Slack, it could be anything. Now whether the specific Hubot implementation or the specific set of scripts that are available right now might be targeted only to Let's Chat, but augmenting those would be simple. Okay. So we've purposely made decisions in the platform to not tie everything into the platform specifically, but to be able to swap out, to make those interfaces swappable.
Okay, sounds good. I think that answers the question. So, any more questions from the room? Nope, and I don't think there's any more in the chat, so anything else you wanted to say, Christian?
No, thank you guys for having me. I guess it's beer time out where you guys are.
Yeah, it is, some pieces, yeah. You can have an early one, you're done for the day, right?
Yeah, it's never too early, right?
Yeah, exactly. All right. Well, thanks a lot. Thanks for doing this, Christian. And,
absolutely, my pleasure.
Thank you. I'll speak to you later. Okay. Bye-bye.